You're listening to Radio Free Hillsdale 101.7 FM. I'm Josh Barker, and I'm joined today by Dr. Kevin Wilson. He's a very accomplished man, and we're going to talk a little bit about his career. But he's also donated hundreds of fossils to the D.M. Fisk Museum of Natural History here at Hillsdale College. Dr. Wilson, thank you for joining us to talk about all of this.
Very glad to be here. Thanks, Josh.
So we're going to start with the fossils. Tell me about your personal interest in fossils. You've collected hundreds from around the world. Just remarkable. What first interested you in paleontology?
My PhD is in geology. I thought when I was a young man that I might be a paleontologist. I took several advanced courses in paleontology, and I found them interesting, fascinating even. But along the way, I had a family, and I decided to do what's practical, which may or may not have been the right thing. But anyway, that's what I did. So I didn't go into paleontology. And even when I got my PhD, I decided that I didn't want to be that poor, which was perhaps a mistake. But anyway, because I get such a charge out of it now. But anyway, that left it for retirement. So I collected whenever I could all my life. And then when I retired, I decided to get serious.
So when did you start collecting, and how did you get involved in that process?
All geology students in the undergrad level go on field trips, and there are opportunities to collect, and everyone does. And then you get interested in different aspects of what you see. So originally I was not discriminating. I just, anything was fair game. But later I found areas of interest, and where I landed was the thing that interested me the most was vertebrate paleontology. So, reptiles, amphibians, sharks, different, mammals. And then when I retired, I decided to dive into that. And in fact, my wife regrets the one thing she did to trigger this. As a Christmas present, she got me a model of a pterodactyl. And that got me to thinking. And the next time she looked up, I had other things.
So when you find these fossils, you said that you do your own identification. And I imagine that's no walk in the park. I mean, what does that look like? You've got the fossil in your hand. How do you go about researching to figure out exactly what it is that you're holding?
Part of what helps that process a lot is to know the context. So if I know the formation I found it in, other people have probably worked in that formation and published things on it. So if I know it's in XYZ formation and it's in the state of Florida, there's a whole funnel list of what could be there. There might be other things, and it might not be what's on the list, but it could be, and it's likely to be. So that narrows it down. Then let's say it's a mammal. Mammals are often very easily identified based on their teeth. And teeth are the part of vertebrates that's most commonly preserved. They're very durable. So you might not find any other part of the animal, but you'll find its teeth. And as a result, at least for mammals, you can look up in the scientific literature, what do the teeth of a camel look like? What do the teeth of a horse look like? What about this particular camel, this particular horse of this particular age? And it turns out there are a lot of diagnostics. There's a lot of terminology and a lot of folderol that you have to go through to end up with an answer. I've got a cheap little set of metric calipers, and those may come in real handy because you can measure different things on skulls and teeth that give you an idea of what it is you're looking at.
You're listening to Radio Free Hillsdale 101.7 FM. I'm Josh Barker, and we have Dr. Kevin Wilson with us today. We're talking about his fossil collection. So you have 600 fossils, over 600 fossils from 50 countries. You started, as you have already outlined, collecting yourself. You go into a field, find a fossil, there you go. Eventually, you're buying these from other parties. You've talked about the importance of knowing the context in which a fossil is found. How does that change when you're not the scientist who found it in the first place?
Well, it's true that if you know the formation, each formation has a personality almost. You know what it looks like in various places. You know what's in it in terms of fossils. And you know what they look like. You have to know a lot of anatomy because many times you get broken things or parts of things and you have to know how they fit in, which sometimes is relatively straightforward, and other times you sit around perplexed for a while. But the funny thing is, because we live in an age of massive scientific effort, I can get stuff from all over the world and I know what it is. There's lots of publications.
So now turning to our exhibition at the college, again, these fossils will be on display at the D.M. Fisk Museum at Hillsdale, open during the weekdays in the Strosacker Science Center at 214. One thing that's special about this donation and the exhibition is that you're actually working with Dr. Swinehart on the exhibition. And in fact, that was a condition of your donation. Why was it so important to you to be part of this exhibition, figuring out how to display this, and how are you enjoying doing that work?
Well, I work very closely with Tony Swinehart, the biology professor, who's the curator of the museum. I was looking for a place to donate my collection, either while living, if it was under the right circumstances, or at my death. And I didn't want it to just go into a bunch of drawers and sit there moldering for the next 100 years. So that was part of it, and I contacted Tony several years ago, and we hit it right off, and so I met with him and told him that my goal was to help him put the exhibits together, because I don't like how museum exhibits are done all over the world. They're mostly not done very well. They're mostly not very educational. They could be, but you have to tell the story. People don't know what it is. So if you're going to educate people, you have to make an effort to educate them. So I wanted to be part of that, and Tony was open to that, and so we've designed these things together. And he's a fabulous curator. He can do anything. It's just amazing the restoration work he can do to a fractured or a not quite sufficiently clear fossil. He can fix them, which is quite a talent. I don't have it, so we're a good team. But anyway, I do a lot of the background work of, what is the story we want to tell here, and I present that to Tony, and then we talk it out and reach a conclusion, and then I want to tell the story of this animal group or this period of time and what was going on in Earth history then, and what drove what happened.
So when you're going about telling these stories, you've already talked about the research process. How do we know what this is? But there's so much more to the story that you can get from these formations and other things. How much of that story that you're trying to tell in the museum, how much of it is focused on see this part of the fossil, what this tells us certain things, versus the contextual details that someone can't necessarily see when they're up here in Michigan looking at a fossil thousands of miles from where it was found?
You're right. There's a distinction there. You can draw a lot of, let's call it, straightforward conclusions from just looking at the thing in your hand. And in fact, it's very educational just to have it in your hand, because a drawing in a scientific article or a photo with scale and all, you still don't have the same feel as when you can rotate it around and look at it from different angles and everything. But I do a deep dive into the literature, so I know everything I can know. So, for example, I'm working on whales right now. That's going to be the next exhibit. The various adaptations of whales, which started out as terrestrial animals with 4 legs. And now they are a little different.
That's for sure.
And so I want to tell that story. It's one of the most marvelous stories. And I want to talk about how we know the things we know, which I think is interesting. And I use my wife as the example of the uninformed person who's enthusiastic. And she loves whales, so I think it's in part because she didn't know the things I told her as I was going through learning what I needed to know to tell the story.
Okay, well, you can't stop there. I mean, at least give our listeners a preview. If you could tell us a story, how did whales lose their legs? I mean, it certainly sounds intriguing.
Well, it comes down to this. There was an animal, I guess I'll tell you the name, Indohyus. It's a little deer-like animal, about the size of a mouse deer. So African mouse deer, they're, not much bigger than a rabbit. And they have a habit of diving into the water to avoid predators. They can hold their breath for 4 minutes. And it wouldn't be a stretch to say that someday they might do that and decide to eat a fish. And it turns out that there are deer all over the northern hemisphere that have been seen eating birds and fish. So a deer-like animal from 55 million years ago went in the water and took a bite and decided that maybe the bite should be followed by another bite. And now the deer didn't decide to change, but the way nature's set up, it works out that way because the deer might have survived longer and reproduced more effectively. So this little deer was found as a fossil by a guy named Hans Thewissen, who's one of the big whale experts. And they had it in a lab in Pakistan, and or was it India? The formations go right across the border, so they find them on both sides. Anyway, he had it in the lab, and his lab technician dropped the skull, and it shattered. And when he picked up the pieces, he might have said something not quite okay, but when he picked it up, he saw something amazing. It had a whale's ear in a deer's body, because whales have the bulb of the ear. It's called the bulla. There's a piece of it in whales that's super thick, called the involucrum, and the opposite side of this rounded bone is thin, and that's only found in whales, and it's not found in any other kind of mammal. So to find that in a deer-like animal was interesting.
You're listening to Radio Free Hillsdale 101.7 FM. I'm Josh Barker, and we have Dr. Kevin Wilson with us, talking about the fossils he recently donated to the college, and it's the Fisk Museum of Natural History. We have two seniors, or at least two that I'm aware of, my classmates, who are working on these fossils as part of their senior projects. Have you seen their work or been involved with any of that?
No, I've been told that about a couple things going on, but I haven't really followed up on that.
Well, I know they're very, very glad to have access to fossils like that because that's certainly not a given or even usual for an undergraduate experience.
Well, that serves my purpose. I'm happy.
Well, I want to turn the last few minutes that we have remaining to discuss your career. Fossils have been sometimes professional, sometimes more of a hobby, but you've been involved in a lot of different things early in your career, and perhaps maybe related to whales, you were involved in the oil business. So you're in the oil business in the late 70s. How did these experiences contribute to your knowledge and telling the stories and understanding the fossils today? Tell us a little bit about that experience.
Well, I got into oil because life happened. I had two babies, and I had been accepted for a PhD program with support, and I had to turn it down because we were as poor as church mice, and I needed to get serious about things with two babies. So a friend of mine was at an oil major, and he arranged an interview, and it was 1979, early in the year, and that was the top of the oil boom of the 70s, and you could get a job by showing that you could breathe. So if you had a geology degree, and so I had a master's, and that was the optimal degree for those kind of jobs. And they were confused. They thought I was at the leading edge of science, which is pretty funny because they didn't understand my thesis. They read it and they thought it was really significant.
What was your thesis?
It was the diagenesis of organic matter in marine sediments of Bermuda. And I went to Bermuda to get the field data,
nice.
Which was definitely a good plan. But anyway, so I ended up at Phillips, and my wife and I both said, well, we'll hold our noses and take this job because it's practical. We're not going to like it. And I was surprised. I didn't like a lot of the people in oil because the motivating factor is greed, which doesn't bring out the best in people. But the work itself was fantastic, and I was good at it. In fact, I was a natural. I found a lot of oil.
So after all this, you turned down grad school in the late 70s, but you do go back and you end up getting that PhD, becoming a professor. Not necessarily connected to fossils, but certainly the Earth's history. I'm told plate tectonics is an area of study. Tell us a little bit about that.
Well, that was another accident. I had funding to do a what's called a sediment mass balance dissertation at Colorado. Sediment mass balance is taking all the sediments that are in things like the Orange River Delta in Africa or the Mississippi River Delta and restacking it onto the continent where it originally was, which you can figure out. Not all of it, but a lot of it. So the Mississippi drains the Rockies. So you could restack it on the Rockies. You have to adjust for how much it's been uplifted and how much the weight of the sediment is and all this stuff. But anyway, when you do that, you learn all kinds of things. Well, as I got started on that work, I discovered that the first thing you have to do is look at the continental shelves and adjust them for the distortions that happened because of plate tectonics. They were stretched. When the Atlantic opened, the continental shelves facing the Atlantic were stretched. And that thinned them out, which let them sink and then eventually be broken by magmatism, and you got seafloor spreading in the center. Well, and that's what created the Atlantic Ocean. Well, I discovered that the corrections for that stretching were all wrong. And so I went to my PhD advisor, who was a world-class, famous geologist named Bill Hay, and he said, well, let's go after that. And he always said that. So we went after it, and we produced answers for how to do the de-stretching routine, and we published that. And then I said, well, really, there's more problems. And he said, well, let's do that. And I said, well, Bill, I think we ought to just pick one of these to be my dissertation and not do all of them. So he thought that was okay. So I picked plate tectonics because it sounded like fun.
Now, what's so amazing about that's just graduate school. Then you get your PhD and work for several decades. We're coming up on time, but I'd like to end by asking you about some of the highlights there since then. What would you say have been your favorite big research projects or endeavors that you've undertaken?
There are a couple of things. When I did my PhD dissertation, it was on global plate tectonics. So I was doing maps of the world as it used to appear all through the Mesozoic. So that'd be Triassic, Jurassic, and Cretaceous from 250 to 66 million years ago. 252 to 66. And I got a raft of publications out of that, which is not usual for a PhD. Most PhDs never get published. But anyway, I was lucky. And then as I pursued that, my maps could be used as a base for running paleoclimate models. So at the time, my professor was hooked up with NCAR, National Center for Atmospheric Research, which was right there in Boulder where I was going to school. And I met all those folks, and we formed a research group. And right as I was graduating, we proposed an NSF grant with NCAR to go take my map base from my PhD and use it to model Triassic climate, which we got the grant and we did it. And we used the big global climate models of that time period, late 1980s, and we showed that the entire world was monsoonal in the Triassic.
All right, well, that's all the time we have for today. I think this really shows to our science students there's really no limit to what you can do with a science degree. And we thank you again for that. Again, anyone interested in seeing Dr. Wilson's fossils is able to visit the Fisk Museum and the Strosacker Science Center at Hillsdale College. You can follow some updates of the project at their Facebook page titled the Daniel M. Fisk Museum of Natural History at Hillsdale College, or visit the Hillsdale website for more information. Again, I'm Josh Barker, and you've been listening to Radio Free Hillsdale 101.7 FM.